Hello my champions, how are you all? Welcome to our platform Diksha Karnataka, where learning is fun, where your formulas meets tricks and your stress of the preparation, the entire syllabus meets a strategy, a proper focus framework which helps you succeed, which helps you ace examination. Okay, so today as you know is session number 2 of inverse trigonometric functions. Yes, so we have done the part 1 where we discussed domain, range, graphs, right? I did not only just show you the graph, I taught you how to draw them, how to obtain these graphs of various ITFs. Okay, now today we'll talk about properties. So let's start the session. I hope you're ready, as excited as I am, beginning with the first thing, which is the planner. If you see, as I said, domain, all the graphs we discussed in the part 1, part 2 will be the properties of ITF, the properties of ITF, and part 3 will be CET PYQs. Moving with the part 4, which will come after the part 3, which will be JEE Mains PYQs. Same goes with the structure of Sankalp batch. First you start with concept session, next comes KCET PYQs, followed by JEE Mains PYQs. This is clear? What is there? So our goal today, okay, for this particular session is to ace these concepts, to ace these questions, to get ourselves one step closer to our dream college. And yes, your seniors have done that. You can see all the names here: Prajwal, Kiran, Diksha, Samiksha, Sachin, Harshit, Chinmay, we have Tanmay, Mohammed Sahil, Kirtana S, Atharv, Anshuman, Akash and Gagan, all the seniors and many more who have just studied from YouTube and got a very good result, okay, in their KCET examination of 2025. Okay, what is our goal? To work so hard this year so that your name, your photo should come over here with your rank in the CET. Okay, that's our goal. Let's move on with the session. So again, if you look at the chapter inside, that you know very well, it's a building block of your calculus. Yes, the questions comes from here as well. 2 questions can be expected in the, so even the last year 2025 paper of CET, there was 2 questions as the PYQs. When we do the CET PYQs, I'll show you the questions. Okay, so every year 2 questions can be asked from this chapter. Very easy and direct questions. Apart from that, this is also a building block for your unit like calculus. That's very, very important, right? One of the high weighted chapter, one of the difficult chapters as per students is calculus, right? The entire unit. So in that, this plays a vital role. The ITF plays a vital role there, whether it is differentiation, whether it is integration, whether it is applications, everywhere it is very, very important. Okay, again direct questions are of course there. So that is our, that is what we're gonna pick out from this chapter. Again, what you should know, your goal is to ace these things. Domain of course comes with the range, and properties, also properties. If you know this for all the functions, all the ITFs, you'll be good, okay, to solve any question. If you can know the graphs also, then very good. That's an advantage to have. If you know the graphs also, that's an advantage to have. Moving on. So if you look at what you're going to do in the session today, so first of all we'll see what we did in the previous session. Basically we'll talk about some domain and range for a minute, then we'll start with properties of ITF, and then I've taken total of 10 questions over here. Okay, 10 questions over here along with your one homework question I gave. Remember, previous class I gave one homework question that I'll discuss as well before starting my other questions. Okay, the practice, before starting the practice in the session itself, I'll solve the homework question also. So total of 11 questions we're going to solve in the session today. Let's start. So first thing first, let's talk about, so I saw some of your answers. I gave one thing to ask you from all. What is the range and domain of second inverse function, right? Some of you got it wrong. So there's the answer. Your domain is going to be what? Please check. R minus 1 to 1. What it means is, if I take on the number line 2 numbers minus 1 to 1, okay, here we have negative infinity, here we have plus infinity, then my result will be, please check, this is my answer. So all this area including 1, minus 1 sorry, and including 1 also, all this area will be the domain, okay? So anything between minus 1 and 1 is not part of the answer. Please check between minus 1 and 1. So I write here open, this is not part of the answer, this is not there, okay? Only this area. And how do you write that? Basically you write like this. So your domain for which one? For second inverse is given by negative infinity to minus 1 Here open, of course, because of the infinity we always have it open. Okay, here it's closed, union from 1 to infinity, again infinity will be open. This is the domain of your second verse, and the range is 0 to pi except for pi by 2. Why except for pi by 2, dear? Because cos pi by 2 is 0. Remember, cos 90 is 0. So 1 by cos will become undefined. 1 by 0 will become undefined, right? That's why the pi by 2 is not present there. Check it out, this is removed, right? Pi by 2 is removed. Makes sense to all of you? Okay, so others, I hope that is very simple for all of you, right? Sine inverse, cos inverse, already explained it to you. Sine inverse, cos inverse, tan inverse, cosec inverse, cot inverse, all was explained, right? So can I move on next? Okay, so this is a list of all the domain and range, which is very important to solve questions in the chapter, whether it is in calculus or whether it is in direct questions of, this chapter itself. Moving on, the graphs, just to give you a summary of the graphs. Okay, for each of the function, here the summary is range is minus pi by 2 to pi by 2. This is for sine inverse of x. Okay, this is for sine inverse of x. I hope you can see this over here, sine inverse of x visible. Yeah, and domain is minus 1 to 1. Your range is minus pi by 2 to pi by 2. Again, both inclusive. The graph is over here. Okay, and don't worry about this, you can download the class notes very easily. If you have joined the WhatsApp channel, you know the access will be there only. If you have not joined, if you are new to the channel, do one thing, in the link in the description of this video, you'll find the link over there for the WhatsApp channel. Join the WhatsApp channel, you'll get all the class notes in the PDF format. You can download it there, revise and solve all the questions again. Okay, so this is the graph for sine inverse of x. Moving on, we have for cos inverse of x. I have taught you how to draw these graphs. Remember, go back and see the part 1. If you want detailed understanding of the graphs, go ahead, watch the video ITF part 1. Okay, this is your tan inverse of x. Moving on, we have for cosec inverse, sec inverse and cot inverse. Again, domain range is listed over here every time. Kindly check. Okay guys, not a problem. The graph is also drawn. I've also talked about the nature of these graphs, whether it is increasing in nature, decreasing in nature, whether it is odd or even. I've talked about all of that. Please go ahead and revise from the part 1 of ITF. Works? Moving on. So next, the session today talks about the properties of ITF, right? So let's have a look, quick look. So what is there, sir? So we write the function, remember, like this, sine y equals to x. Same thing can be written in the form of sine inverse. I take sine inverse over here, I get y equal to sine inverse of x. So I have two equations now. Either write x as sine y or write y as sine inverse of x. Make sense? Okay. If you use them together, okay. So basically I'm asking you to do what? 2 in 1 and 1 in 2. 2 in 1 means basically I'll put the value of y. What is the value of y? Sine inverse in place of y in sine. Confusing? I'll repeat myself. Okay, what is the first equation states? Sine of y. I am asking you to do what? Replace this y by the value of y that you have in the equation number 2. We can do that. So replacing this y, sir, by the value of y, sir, which is sine inverse, you said, sir. So this. Okay, what is the answer going to be? The RHS is simply x. The RHS is simply x only, right? This is the RHS. Remember, this is the same thing I've written over here. Using equation number 2, in 1 we get this result. So sine of sine inverse of x is nothing but the value x itself. This is my first result from the properties segment. Okay, next one, using 1 into. Using 1 into, how can you use that? So in this case, we'll get the value of x from the 1, put it over here. Check here. So I have in this case y equals to sine inverse, right? Of what I have? Sine inverse of x. Where's the value of x? Value of x is over here, which is sine y. Value of x is sine y. Okay. So whether you write sine inverse of sine or sine of sine inverse, result will be the value over here. Remember, sine inverse of sine is simply y, and over here also sine of sine inverse is simply x. Please check, sine of sine inverse is x and sine inverse of sine is basically y. Okay, I can write here x also, any variable. Okay, I can write. Okay, I can write any value, any variable. The property is whether you operate sine on sine inverse or sine inverse on sine, they'll cancel each other. Reason? They're inverse functions, right? So the effect will be cancelled out. Okay. Sine and sine inverse are two inverse operators which cancel each other. Likewise, we can also say for same thing, logs and exponential function. So e power x or ln x, they are inverse to each other, also cancel the effect. If I write here e power ln x, answer is simply what? Simply x. Okay, great. So similarly we have, so sine and sine inverse is one such pair. We have cos inverse with cos. We have tan inverse with tan, cot inverse with cot, and of course you know that now sec inverse with sec, the other pairs, cosec inverse with cosec. Okay, so if you operate it like this together, they simply cancel each other out. They simply cancel each other out. Okay, moving on. Now some properties to be listed over here. So same thing written over here, please check. Sine inverse of sine x is x, cos inverse of cos x is again x, tan inverse of tan x is again x, and likewise for cot inverse, sec inverse and cosec inverse as well. What is this? Their domains. What is this dear? Their domains. Please check. Okay, what domains are? Domain of what? This value, sine x. Domain of sine x is what dear? Minus pi by 2 to pi by 2. Not the inverse. For inverse, please remember, sine inverse x domain is what? Is minus 1 to 1. Remember, this is domain of sine inverse of x. We are not talking about that domain. We are talking about the sine domain. Okay, that is minus pi by 2 to pi by 2. Same goes over here for cos x, 0 to pi, and we do that. Remember, as somebody was asking me in the comment section, what is truncating, sir? Okay, truncating means basically, cutting something. Means we have a whole part. We have a whole part. I want to take only this part. Can you see only the tip part? Okay, or over here, I want to have only this part with me. Okay, I can just truncate it, cut it out. Cut it out is basically truncating. Okay, got it. Remember the word was restricted domain. So for the entire domain that we have, we cut it out to use only the restricted domain. For example, remember, so we had the case of sin x, remember? So the graph was like this. Actually the graph was over here also and over here also, but we did not take that part. We only took this part. So the domain is now restricted. What is this called as? Domain is now restricted. So basically, how did you get the restricted domain? By truncating the other part. This part has been truncated out. This whole part is truncated out. Got it? So this is called as your restricted domain. What was it? Minus pi by 2 to pi by 2. In the case of cos, it was 0 to pi. Remember? 0 to pi. It was like this. This is the cos x after what dear? Domain restriction. Domain restriction. We had this graph for cos x. And this is the graph for sin x. Looks confusing. I erase the extra markings over here. Okay. So this was the, again, graph after the, excuse me. 1 second. Something is not right. Yeah. I'll remove this. So this solid part you can see over here was the graph after the domain restriction. Works out, all of you? So I just saw this query, the doubt was there in the comment section of the previous video. That's what I'm dealing with over here. Moving on, next one. So some more properties. So there's not many, okay? So these are the very important ones. And apart from that, I'll give you one more set. Before I go to this, this is a very important one. Sin inverse of x plus cos inverse of x is pi by 2. It is pi by 2. Doesn't make sense to you? I'll show that over here. Please check. Let's say this is my value, some angle alpha. Okay, so some angle alpha. This is my value, let's call it perpendicular, base and hypotenuse. Okay, great. Let's call this to be beta. Let's call this to be beta. If I say sine if I call this to be alpha here, I can write sine alpha as, remember, sine alpha as p by h. And is it the same as x actually? Yes. Okay. So basically I'm getting this sine alpha as p by, not x, sorry, p by h. This is p by h. Okay. Now same way I can write cos alpha also. I get cos alpha as, please check from here, cos alpha. I can't do that, no? I can't do that. But if I try to write that, if I try to write this value cos alpha, I'll get what, dear? I'll get b by h, b by h. This is not same as this. I hope you get it. Okay, I'll show you why. But if I want to write this same thing, b by h, in terms of this value x, so now if I write cos beta, I'll tell you why, because I want to get the result in terms of p by h only. Check this out, cos beta. From here, this angle cosine I'm writing. That angle's beta I'm writing the cosine value. Have a look. So I'm writing here cos beta. What I end up with? So I get cos beta as p by h again. And isn't this value p by h is same as this value x? Please check. This value p by h, I repeat myself, is same as x, right? So I can write this also as x. This also as x. Check carefully. So if I combine these two together, I can write this as beta equals to cos inverse of x. Cos inverse of x, how can I do that, sir? I have cos beta equals to x. I'm moving the cos on this side. Moving the cos on this side, I get what? I get cos inverse of x, and this side I'm left with beta. Okay, check this out. Cos inverse of x will become simply beta. Check this out over here. Alpha plus beta. What are those angles? If this is the right angle triangle, if this is a right angle triangle, okay, then alpha plus beta will be how much, dear? Pi by 2, hence proved. So I was trying to justify why this statement sin inverse of x plus cos inverse of x is pi by 2. What I did, I'll repeat again, what I did was simply I took over here one of the angle is alpha, and for that I wrote sin alpha. For that I wrote sin alpha, I got p by h, this p by h, okay, which is same as x. Please check. If I take sin inverse of x as alpha, if I take this two value equal, right? If I take sin inverse of x as alpha, what I get from here? I get sin alpha as x. I get sin alpha as x, correct? Okay, now from there only I can see, so I am getting this sin alpha as x, which is p by h. If I write another angle beta, that beta will become cos beta, will be having the same ratio p by h, again adjacent by hypotenuse. So cos beta will become p by h, here p by h, which is same as x. This p by h ratio is same as the value, the variable x. Okay, repeat again, take the cos inverse on this side. You have beta value as cos inverse of x. Replace the cos inverse of x as beta. This as alpha. I'm getting alpha plus beta as some value, right? Not pi by 2. What is that angle? Please check. If this is a 90-degree angle, this other two angles sum will be 90 degree only, right? Hence we get this value as pi by 2. Is that clear? Tell me, is that clear or not? Yes, it is. Okay, so we have the first condition true. Second, we again have two more pairs. Okay, we have two more pairs. I can write it over here. I can write two more pairs over here. So second pair is tan inverse of again x plus cot inverse of x equals to pi by 2, and third pair is for sec inverse of x plus cosec inverse of x equals to pi by 2. We rarely use the third part. Most of the time we use first and the second one. First and the second one. Tan inverse of x plus cot inverse of x is pi by 2. Again we have sec inverse of x plus cosec inverse of x is pi by 2. But most of the time we use first and second only. Now moving to the properties on this side. Very simple ones. Odd function comes out as minus sign. Odd functions again comes out at minus sign. But please check this out. Cos inverse, not an odd, neither even. Okay, so we get here result as pi minus cos inverse of x. How do we get it? Not important for us. Okay, if you remember the formula, that's good enough for us. Okay, again we have here 3 a, b and c. We have d also. Let's write here sin, cos, tan. I can write next. So next will be, sir, cosec. If I'm writing, no, cosec minus cosec inverse of minus x. I get the same thing, minus cosec inverse of x. But if I go to sec inverse, okay, sec inverse of minus x, my answer will become like cos pi minus neither even nor odd. I hope you're getting it right. I taught you this yesterday. Sin, tan and cosec are odd functions. Sin, tan and cosec are odd function, whereas cos, sec and cot are neither odd nor even. Okay, so we have sec inverse minus x as pi minus sec inverse of x. Same goes with the last one, cot inverse. cot inverse of minus x becomes pi minus cot inverse of x. You'll see the results. I'm going to use it right now to solve the questions. Okay, this is a different set of property, and this is again a different set of property. Please check. This is different. Okay, first, second, third over here, and these 6 are over here. Clear? Very important. All the questions you are gonna see right now will be using these properties to solve the problems. Okay, I hope this is clear. Moving on. Okay, now time is to solve the questions. Notes we're gonna get. Join the WhatsApp channel and get all the notes in the PDF format. Okay, right now question number 1, this is the homework. If you remember, this was the homework, a principal solution of cot inverse. What is the meaning of principal? That restricted, we are talking about the restricted domain, talking about the restricted domain. Okay, chali. So value that comes out of this, how do you solve this question? So cot inverse is there with a minus sign, minus 1 by root 3. This will become pi minus cot inverse of 1 by root 3. Okay, please check. Pi minus cot inverse of x, right? Here x value is 1 by root 3 because minus sign comes out. Great. So this is going to be pi minus this value is how much, sir? Cot inverse of 1 by root 3 is how much? It's going to be pi by 3. You have to remember the table, okay? So sine, cos, tan. I've taught you that in the bridge course. Go ahead, check that out. Okay, I've given you shortcut also to remember it. If you don't know the shortcut, if you know, very good. If you don't know, check the bridge course, okay, and you'll get the understanding of how to get this or remember these values. Okay, special angles are there, right? 0, 30, 60, 45. I missed. Sorry, 0, 30, 45, 60, and 90. You have to remember the values of sine, cos, tan, and others, basically all the 6 trigonometric ratios at these special angles. Okay, so pi by 3, I get this value as 2 pi by 3, right? Option A is right. Option A is correct. So couple of you have given me the right answer in the comment section of the first part. I checked that, it was very good. Others, please try to solve it. Others also, please try to solve the question that I give you as work. Okay, next one, question number, okay, now this is question number 1 from the homework, okay, the previous session. Today's practice session will have again starting from question number 1 to question number 10. Let's solve all of this. First one, sine inverse of sine. What is the answer, sir? The angle itself. Answer is option A. Remember this definition of this property, sine inverse of sine x is nothing but x. What is the value of x over here? Pi by 3. Answer is option A. Directly done. Moving on. Okay, done and moving on. Question number 2. First one is easy, right? Yeah, straight on the property. Tan inverse of tan 3 pi by 4. I have to make some changes over here. There comes the rule of quadrant to be also utilized. Have a look. Tan inverse, I have tan over here with 3 pi by 4. I can write this as tan of pi minus pi by 4. Pi minus pi by 4. Please check. 4 pi minus pi will be 3 pi by 4. Same thing written here. So far nothing is changed. Now I'm going to use the quadrant rule. Which quadrant is the angle in? Second quadrant, sir. Second quadrant. Pi minus pi by 4 is in the second quadrant. Tan is negative in the second quadrant. Tan inverse will remain as it is. This is negative. Comes a minus sign. At pi, the ratios does not change. Okay, so remains same as tan pi by 4. Tan inverse of tan. Tan inverse of tan is what, dear? Remember this property over here? With a minus sign, if I have, becomes minus tan inverse of x. Okay, great. So what I have over here is going to be minus tan inverse of tan pi by 4. We have learned this, sine inverse of sine, cos inverse of cos. They are inverse functions. It means simply they will negate each other. Okay, cancel each other out. Answer will become minus pi by 4. Okay, we don't have to take this much of time to solve this question, but I'm taking it over here because this is the first problem, okay, of this category. Answer is option B, right? Option B. Moving on to the next question, question number 3. Okay, cos inverse of cos 7 pi by 6. Okay, let's try this. Cos inverse cos 7 pi by 6. Again, we have to use the quadrant rule, but we have to break the angles first. Okay, so I can write this as cos pi plus pi by 6. I think that will work. Please check. Sum of these two angles. If you take the LCM, you'll get 6 in the denominator. We have 6 pi plus pi, 7 pi by 6. Same thing over here. That works out. Which quadrant is this? Third quadrant. Pi plus, right? So third quadrant. Okay. Third quadrant, cos is negative. It means there comes a minus sign. So cos inverse, there's a minus sign. At pi, the ratio does not change. So remains as cos. Again, you have pi by 6. Okay, cos inverse of this will become what, dear? Remember the formula is pi minus cos inverse of, the same thing will repeat, cos pi by 6, cos pi by 6. What I have, they'll cancel each other's effect. We have answer as simply 5 pi by 6, right? Option A is correct. Option A is correct. So very important to know the quadrant rule. Once you know that, remember here all is positive, all positive. Here we have sine and cosec positive. Here we have tan and cot positive. Here we have cos and sec positive. Got it? All right. So this is the result. Step 1, 2, 3 and 4. You got to figure out how to break the angles. Once you are able to do that, no, the rest of the steps are very simple. You can do in your mind also. Answer is option A. Okay, they might seem very simple to you, but similar question has been asked in the your exams as well. Okay, so you have to remember this. This is what I mean when I say direct easy questions. They can be asked in either boards also as well as in a CET examination. Okay, some questions will be easier, right? And this is the chapter where easy question can be asked from. This is a PYQ. Okay, let's solve this question. Very simple. Sec square of tan inverse 2 and cosec square of cot inverse 2. What we're going to do? Simply write sec square in terms of tan. This is a formula, remember, identity we have. 1 plus tan square is sec square. 1 plus tan square theta is sec square theta. Same we have for 1 plus cot square theta is cosec square theta. Okay, so we have 1 plus tan square of tan inverse of 2 plus 1 plus cot square of cot inverse of 3. Okay, now how do you solve this? 1 plus tan of tan inverse of 2. This, of course, this is a whole square, right? This square is a square on the tan, right? So again whole square will come. This square you see is a square on the tan. So this square will give the same effect, right? It's a whole square. Okay, same over here. Plus 1, we have cot inverse of 3. Again we have a whole square. Okay, check this out. 1 plus 1 makes 2. So right here 2. Tan inverse of tan. So tan of tan inverse becomes the value itself 2, and we have whole square, so whole square, plus this side we have again value as 3, so 3 square. Cot of cot inverse, cancel each other, inverse of each other's. 3 will be the answer, and there's a square, so 3 square. I get 2 plus 4 plus 9. The result is 15. The result is 15. Be careful. I hope this is all making sense to you. Answer is option number D. Answer is option number D. Great. Simple question. Simple question. It's a PYQ. Okay. Moving on. It's a previous year question. This is from 2025 CET. One of the sets. Okay. Fourth is done. Next question. Have a look before I move on. You might feel that I am going a little fast again. Am I? I hope not. If I am, let me know in the comment section. Whatever is your query, please put it in the comment section. I'll read them, and accordingly we'll make changes. We'll make the sessions better and better. Okay, this clear. Moving on. Now question number 5. Okay, it's a good question, but similar kind. 33 pi by 5. How do you break it? Sine inverse we have. I want sine, of course, because sine inverse on cos will be, of course, nothing. I have to make cos into sine. That's the challenge. First, let's write in simplified manner. 6 pi I can do plus 3 pi by 5. Correct now? 6 into 5 is 30. 30 pi plus 3 is 33. 30 pi plus 3 pi is 33 pi by 5. Okay, at 2 and pi we know that cos of 2n pi plus theta is simply cos theta, right? We're going to use that over here. Okay, we're going to use that over here. So I get sine inverse cos 3 pi by 5. 3 pi by 5. Alright, in terms of sine, how do I do that? With the help of pi by 2 minus 3 pi by 5. That's how it works. Remember, sine pi by 2 minus theta is simply cos theta. Okay, great. What do we have next? Okay, so this will become what, dear? Okay, I can simplify this. Sine inverse of sine, the value, if you check, the LCM is 10, the angle. Because if you write this, no, we can go back to this position, right? From the third step, we can simplify it back to the second step. I'm writing the expansion of this. I want to write cos in terms of sine, that's why I've done that. Next is what? Simplifying the angle. LCM is 10, 2 5s means 5 pi over here. And over here I have 5 2s means minus 6 pi. Clear? Okay. Next set of steps, have a look. Sine inverse I have with sine, and the angle is 5 pi minus 6 pi, which is minus pi. So minus pi by 10. Okay. So this will come out. Sine inverse of sine is going to be cancelled. They are inverse of each other, inverse of the trigonometric function. I get the answer as simply minus pi by 10. That's your final answer. Minus pi by 10. Option D is correct. Option D is correct. I hope all of you got it. Okay, it's a good question. Not difficult, but it's a good question. Decent problem. Okay, 6th question now we'll solve. Alright. Now for this question, before I move on, I want you to solve this first. So do one thing, pause the video, solve it, come back and check the answers. Okay, first try from your side, then come back and check the answers. Okay, pause the video over here. So let's start the solution now. Okay. The value of 2 sec inverse of 2 plus sine inverse of 1 by 2. If you know the table, you're going to get it right. 2 times of pi by 3 will come over here. Okay, because cos inverse, cos inverse of 2 will be, 1 by 2 will be what, dear? It will be your pi by 3. That's why second inverse becomes again pi by 3 for 2 itself. And this will be pi by 6. LCM over here is 6, 2. So we have 3 2 means 2 2s, so 4 pi plus pi, 5 pi by 6 should be your answer. Option B is correct. Please check. Option B is correct. Simple enough. Simple question. I hope you all got it. Yeah. Next. Question number 7. The principal value of sine inverse cos of sine inverse of minus root 3 by 2 might look complicated, but it is actually very simple. I'll show you. So what you do in this is simply starting from here we'll solve. Okay. Then we'll go backwards to the sine inverse function. So let's start. Sine inverse of cos. You can do again one thing. Please pause the video, try from your side, and then come back and check your solutions. Okay. Give a fair attempt. Okay. For all of you, you keep asking me in the comment section. No, so I didn't get it. I can explain again why this happens, because I am solving the question. So you might not know the connection with the question and concept. So do one thing. Pause the video, solve from your side first, and you'll see, okay, when you come back, even if you can't solve the problem completely, but when you come back and see the explanation, no, it will be more, you'll more be able to relating with the problem. You can relate better. Getting my point? Okay, please try. So for this part, I'll have simply minus sign over here, because sine inverse of minus x. I'm writing the properties I'm using. Sine inverse of minus x is how much, sir? Simply minus sine inverse of x. First property used over here, so I get here minus sine inverse of this angle will become pi by 3. Please check. Sine inverse of root 3 by 2 is what? 60 degrees. So pi by 3. Okay. Next, cos of some angle doesn't matter. It's going to be positive only, because cos 4th quadrant here. Second property is cos of minus x is what? Cos x is an even function. Cos inverse is neither odd nor even, but cos is an even function. Okay, because in this quadrant what happens is cos and sec is positive. Cos and sec is positive. So cos of minus this value will become simply cos of pi by 3 only. Nothing changes. Okay, so I get sine inverse of cos of pi by 3 is how much? 1 by 2. and this becomes what, dear? The final step. This becomes simply pi by 6. Sine inverse of 1 by 2 is pi by 6. Answer should be option B. So looks difficult, but it is actually a very, very easy problem. Very, very easy problem. Makes sense? Okay. 7th is done. Okay. Fine. Question number 8 will start now. Find the domain and range. It's a very complicated question. Looks difficult, will not solve it. Very easy, I'll show you. Okay, just give complete attention. Put your pen on the paper and don't have to write anything. Just all attention on the screen. Okay, for next 2 minutes. That's all. So we have tan inverse of log. The base is given as 4 by 5, which is less than 1. Okay, doesn't play a role over here, but all right. 5x square minus 8x plus 4 is where our whole energy should go in. Okay, so we have two functions over here. First function is tan inverse. Good thing about tan inverse is domain is what? All real. Domain of tan inverse is what, dear? Is all real, means from here to here. First is a very big relief for us, because first function is dealt with. Second is logarithm function. Okay, second is the logarithm function. Let's check how it works out. So only problem that will be created will be because of logarithm function. So that has to be on this. So log function means this part 5x square minus 8x plus 4 should be always more than 0. Log does not operate on a negative value. Remember the log graph. In this case, the value of the base is less than 1, means the graph. This is the graph, right? This is your graph, okay? So you can check, is there a negative value of x where the log operates? This is x value, right? Will there be a negative value? Can you put the value of x as 0 also? No. We can't have any 0 also. We know that's why there is no equal to sign over here. There is no equal to sign over here, only greater than 0. So we have to just satisfy this condition. So the question is, the next step is, for all you students, what are those values of x? Question, remember this question. What are those values of x where this entire equation will be more than 0? More than 0. So whenever you have a condition like this, whenever you have a query like this, that for all those values where x will be, where this entire equation will be more than 0, whenever you have a situation like this, find the discriminant. Please write it down, find the discriminant, okay? B square minus 4ac. Not only this question, whenever you see in any part of calculus, you're talking about dealing with your the equation where it is whole quadratic has to be more than 0. Simply find the discriminant, your job will be done. Find this value. So you get b square means this minus 8 square. So becomes 64 minus 4 times of a. What is a value? 5. Please check. B square is 64 because minus 8 square is 64. 4a means 4 into 5 and c is again 4. 64 minus, what is this? 16 into 5 minus is minus 80. Minus 80, answer is what? Minus 16, right? Minus 16, correct? Now check this out. So I'm getting the value of discriminant is less than 0. What it means actually, remember, quadratic curve, when discriminant is less than 0, the graph lies above the x-axis. Whenever the discriminant of a quadratic equation, is less than 0 or negative, the roots are imaginary, okay? There is no real value of x and the graph lies above the x-axis. What it means, this whole graph, whatever is this value graph, always is going to be more than 0, no? Above the x-axis means what? This entire graph, whatever is this graph, y, call it y, this y will be always more than 0. Okay, it means that for any value of x you take x over here, doesn't matter. For any value of x, the graph is always above x-axis. It means that y is always positive. It means that this is always true. For any value of x, for all real values of x, okay, of x, the given here the statement 5x square plus, sorry, not plus, minus here, I'll just change that, minus 8x and we have plus 4 is always positive, means whatever value you want to take it, it will be always coming out as positive. means your domain for the graphical, this logarithmic part is also all real, hence your final domain is all real, basically minus infinity to plus infinity. That's your final domain. Please check. For log also is the same thing, and for tan inverse also same thing. It means answer is the final domain. Check, only one option is like that, option A, that's your correct answer. But if you want to check for range also, I'll tell you, don't worry about that. But understand this, if you are in hurry, if you see that there's only one right choice like this, is option B has this domain? No. Option C? No. Option D? No. It means only one such option. Answer is option A. Quickly solve it and move on. But if you want to know the range also, give me 1 second. Just give me 1 second. Have a look. Okay. Now talking about the range part. Range of what, dear? Range of what? Range of tan inverse. Why, sir? Because log will give you what? The log output will be always all real. I just showed you the graph. The log was going from negative infinity to positive infinity. This is a graph, right? Log output is all real. If you feed that in tan inverse, it will give you the range of tan inverse. So basically the range of tan inverse will be your answer. Okay. And what's that? What is that? We know this value very well. Minus 5/2 to pi/2 open. This is what, dear? Basically this is the range of tan inverse of any value, let's say y. Okay, got it? Now check the most suitable option. Isn't this the most suitable option? Minus pi/2 to pi/4. Will this work or not? Of course this will work, sir. If I take this a number line, minus pi/2 over here and pi/2 over here, this given statement in option A is basically means that starting from here, which is open again, and goes to somewhere over here, pi/4, and this is closed. Is this green part a subset of this yellow part or not? Yes, it is. So whether you take this, if you don't have this option, will you choose this option or not? You can choose this. Hence, minus pi/2 to pi/4 is the right subset that you can choose from in this particular case. You can choose even this part also, but here the domain is not right. This is not possible. This you can't choose because here it is closed. So this is incorrect. Please check. Pi/2 is open interval. Okay. Here it is closed. We can't choose. This is wrong. Pi is way beyond your pi/2. This you could have chosen. This is correct. This range is correct. But the domain is wrong. This is wrong. Got it? Looks a little messy, but very informative question. Okay. It's a very good question. Question number 8. I hope this is clear. Both the domain and range part. If you have a doubt, ask me. What I'm going to do is if you have literally have a doubt, first of all, watch this video, this question couple of times. Watch it again, okay? Once the premiere is done, go ahead, watch it again, this question couple of times. If you still have a doubt, let me know in the comment section. I will actually solve this question again in the next session. Works out? Okay, let me know that. So the question number 8 is done, and I'll move to next one. Question number 9, okay? The notes where you're going to get, the notes will be available in the WhatsApp channel. Join right away. Okay. Now value of cot of summation from 1 to 23, cot inverse operating on, there's 2 cot over here. One cot, one is cot inverse. Operating on 1 plus k equal to again 1 to n 2k. Difficult? Is it difficult? Not at all. Please check. So whenever you're adding n natural numbers, there's a formula for that. N times of n plus 1 by 2. We know this formula or not? Do we know this formula or not? Of course we do. Okay. So I can replace this whole thing. Please check. So I'll forget about this cot outside. Okay. I'll just start writing from here. Summation n equal to 1 to 23, and right here cot inverse. Okay. Right here 1 plus, and this will become what, dear? This 2 can be a constant kept outside. This 2 can be kept outside the summation. It's a constant, right? 2 is a constant, can be kept outside the summation. And this summation of k becomes this condition. N times of n plus 1 by 2. Cancel this 2 and 2 out. Okay, this 2 and 2 out. Summation of k. What is k, sir? Is a variable from 1 to n. From 1 to n, summation you're taking, natural numbers, will become n into n plus 1 by 2. 2 and 2 is cancelled. Got it, sir. Now what we have? Let's write this in terms of tan actually. write this in terms of tan inverse. Okay, so when I write tan inverse, I get what? I get this again reciprocal over here. So it becomes, right now it was 1 plus n into n plus 1. It will become reciprocal. So 1 upon 1 plus n into n plus 1. I hope you got how I did this step. It was cot inverse, I changed it to tan inverse. That's why I have to change this in the bracket also by the reciprocal. Okay, 1 plus n into n plus 1 was there because 2 and 2 is cancelled, becomes reciprocal as 1 upon 1 plus n times of n plus 1. Why I am doing this? You'll see there's a formula, that's why. There's a formula, that's why. Okay, have a look. Can I not write this number 1 in the numerator as this n plus 1 minus n? So I've changed nothing in the denominator, just change the numerator, writing 1 as n plus 1 minus n. Okay, and then cancel, 1 is what is left out. Okay, no problem. There comes the formula, tan inverse of A minus tan inverse of B. Check this out. Check this out. Yes, this is my value A, this is my value B. Okay, this is again your B and A. The formula, if you remember, tan inverse of A minus tan inverse of B is given by tan inverse of A minus B upon 1 plus AB or BA. Same thing is there, A minus B upon 1 plus AB or BA. Okay, got it? So basically this will turn out to, have a look, 1 to 23 tan inverse of n plus 1 minus tan inverse of n. Same formula I'm using over here. A is n plus 1. Check this out. A is n plus 1 and B is simply n. Tan inverse of n plus 1 minus tan inverse of n. Okay. The steps are clear. Okay. Now check this out. I'm going to substitute it. So if I write the substitution over here clearly, have a look. Starting from here, put the first value as 1. You get 1 plus 1. What is that? Tan inverse of 2. Put over here, you get minus tan inverse of 1. Putting n value as 1. I'll put n value as 2 also. N value as 2, you're going to get what? 2 plus 1. So tan inverse of 3. Over here, minus tan inverse of the value put 2. Please check. I'm putting 1, I get 2 and 1. When I put n as 2, I get 3 and 2. Let's put the last one. What is the last one? 23. So I'll put here dot dot dot. Here also dot dot dot. And the last one. What's the last one, dear? 23. So it'll become 24. That will become 23. So I'll have tan inverse of 24. How come, sir? 23 plus 1. So 24. And there's a minus sign. This will become tan inverse of 23. 23. Right? First I put n as 1. I got 2 minus 1. N as 2, I got 3 minus 2. When I put n as 23, I got 24 minus 23. Okay. Now check carefully. Very good thing is going to happen now. I can cancel something. I can cancel here. Plus tan inverse of 2, here negative. Same way, no? You'll also get, next term will be what, dear? Next term, tan inverse of 4 minus tan inverse of 3. Next term will be, when you put n value as 3, no? You're going to get tan inverse of 4 minus tan inverse of 3. So you're going to get this also cancelled. Got it? When you write here tan inverse of 22, okay, put n value as 22. What you will have? 23 minus 22. Okay, so this also will be cancelled. So what you're going to have left, if you want, do one thing, pause the video right now over here if you're confused. If you're confused over here, do one thing, pause the video and just write this expansion. Write few more terms. Write the terms of n equal to 22 also and n equal to 4 also. You'll have the idea. Okay, what is left now? What is left now? So I can erase this formula, I hope now. I'll erase this formula. Give me 1 second. Yeah. Okay. Almost done. Let's continue. Okay. So I have now what? I have, what is left now? Tan inverse of 24 minus tan inverse of 1. Same formula will apply again what we used over here. I'll apply the reverse format. It becomes tan inverse of 24 minus 1 upon 1 plus 24 into 1. What I get for this step? Continue. Tan inverse of 23 by 25. Okay. So this is still the summation part. I still have one cot outside. I still have this cot outside. Apply this cot now. So I get cot of tan inverse of 23 by 25. Apply tan inverse into terms of cot. Write the statement again. You get here tan inverse in terms of cot. So cot inverse becomes 25 by 23. Please check. Cot and cot inverse will cancel each other. Okay. My answer will simply be 25 by 23. Excuse me. 1 second. Okay. Yeah. It'll be okay. So a little less space I have. This will become simply 25 by 23. 25 by 23. Because we're going to cancel these two, right? Cot and cot inverse will be cancelling each other. Cancel the effect. Answer will be 25 by 23. Option like this. Option B. A very, very good question. Have a look. A very, very, very good question. Okay. All right. This is clear. Have a look. Okay. Moving on to question number 10 now. It might be challenging for you guys because I've used some formulas. Okay. Yes, I understand that if you are going through this video, you know the formula, basics formula that for trigonometric functions. Okay. So if you don't know that, I've written it already over here, but it is now. You can go back and check it out. Tan inverse of A minus B is given by tan inverse of A minus tan inverse of B. Okay, sorry. Tan inverse of A minus tan inverse of B is given by tan inverse of, I can write it over here. Confusing for all of you. Okay. If it is at all. Tan inverse of A minus tan inverse of B is given by tan inverse of A minus B upon 1 plus AB. Now better, right? Now it's better. Yeah. Kindly check. Okay. Clear? Let's move on now. So question number 9 is done. Question number 10, the last question of the day. We'll complete it and complete the session. Again, a difficult question, sir. Very difficult. So you said the previous one was easy, but it came out difficult. It's not difficult. Yeah, it is a little bit, they had more concept in it. But this is very simple. This is very, very simple. I'll show you how. If you can solve this question from here, your question is done in 2 seconds. 2 seconds. Please check. Sin inverse of A, sin inverse of B. Sin inverse of B, sin inverse of C is given by 3 pi by 2. Given by 3 pi by 2. What's the maximum value a sin inverse can get? Range. Check. Range of sin inverse of anything. I have this as minus pi by 2 to pi by 2. The maximum value is pi by 2. The maximum value is pi by 2. Now, how can you add these different numbers to get 3 pi by 2? They all have to be their maximums. Pi by 2 plus pi by 2 plus pi by 2. Correct, na? They all have to be their maximums. Pi by 2 plus pi by 2 plus pi by 2. Then only you can get the sum to be equal to 3 pi by 2. Yes or no? Yes, sum is 3 pi by 2. Once you get that, please check. It can be pi by 2 only when, look at the domain, mass 1 to 1. It means basically the value of A has to be 1, value of B has to be 1, and C has to be 1. A is 1, B is 1, C is 1. Now check this carefully. This is, sir, 1 power something. From here I'm writing. Final answer. Have a look. 1 power something is 1 only. Again 1 power something, 1 only. Again 1 power something, 1 only. A is 1, B is 1, C is 1. So 1 power something, 1 power something, 1 power something, 1 only. I don't have to use any of this. No need to use any of this. Okay. Check over here. We can use it. We can solve it in a more elaborate way, but no need. Have a look. Again, you have what? You have minus 3 into 1 power something, 1 only. 1 power something again, 1, again 1. We have 1, 1, 1 divided by 1 plus 1 plus 1. So 3. Correct, na? A power something will be 1, this also will be 1, this also will be 1. 1 plus 1 plus 1 is 3. Check this out, I'm getting this 3 by 3. 3 and 3 is cancelled. What is left now? 1 plus 1 plus 1 is 3 minus What is this, sir? 1. Answer is 2. Option A is correct. Please check. 1 plus 1 plus 1 is 3, and we have 3 by 3, which is nothing but 1. So 3 minus 1 will be 2. So if you are able to understand this statement, sin inverse of A, sin inverse of B, sin inverse of C, your job is done. Got it? If you want, you can solve this question also using this f2 equals to 2. Okay, you can use f4 equals to, you can write f4 as 2 plus 2 will become f2 into f2, and that way you can solve it, but not required. The answer will be coming directly using this approach. This is clear. Question number 10, option number is A. Question number 10, option number is A, value is 2. Got it? This completes our session today. I hope there is no more question. Yeah, this is the end of the session today. Okay, so if you are here, if you watch the session, if you are new to the channel, please subscribe the channel. Okay, because this is the place, this is the platform where you get a very quality content for your preparation of all the competitive examination for CET, for Comet K. All the content that you want, okay, will be of very good quality, or very, they will not be, this will be a platform where you get serious education. Okay, we are here to provide a very quality education at no cost. The costs are only your efforts. If you are new, subscribe the channel, and very important, turn on the notification icon, because this is educational content. If you miss out on any video, you have backlogs, then again you have no difficulty to follow all the videos, because all within the sequence, right? Part 1, part 2, part 3, part 4, like that videos are coming. If you miss out the first 2 parts, then you can't solve and watch the part 3 video. Correct now? If the part 3 and part 4 are, let's say, CET and JEE Main PYQs, and if you've not watched the concept session, it will be difficult for you to follow the other sessions. Okay, so please turn on the notification of your the subscription. After subscribing, turn on the notification so that you don't miss out on any of the videos. I hope it makes sense to you. So this is it for the session today. Make sure that you have joined the WhatsApp channel. I'll see you again very soon. Till then, take care. Bye bye.